instead of brackets, square brackets, 0, mod 8, I've just written 0 here. And from the definition of a direct product, right, remember it's, you take an element from your first group, comma, and an element from your second group. In this case there's only one element. Okay, so you get an ordered pair of this form. So it'll be naught, and then 1 naught, and then 2 naught, 3 naught. Okay, so this group here has four elements. So the order of this group is 4. Okay, there they are. Right? So the order of your H is 4. And now what's the order of your group G? Well, 4 times 8, okay, 32. So the order of your, the size of your group is 32. The order of your subgroup is, from here, 4 elements, is 4. Okay, 32, 4. So let me ask you, what then is the order in the size of your quotient group? Right? Remember the formula? The order of a quotient group is equal to the order of your group G divided by the order of your subgroup, your normal subgroup, H. Okay? So this is 32 divided by 4. So the quotient group will have order 8. Right? 32 divided by 4, which is 8. And your quotient group consists of cosets. That's what a quotient group, factor group is, right? Just a set of cosets. With the binary operation being what I call coset multiplication. Now in the next session we'll do the problem solving. It'll be the problem solving session. We'll do several examples of subset multiplication. All right. Okay. So the order of the quotient group is 32 divided by 4, which is 8, and therefore this quotient group here has 8 cosets. Now I guess I should say I've glossed over it a little bit. All that is true only if this subgroup here is normal, right? All that theory. Now, can you see why that's so? Look, have a look at this group. Here it is here, right? Fairly simple group. And the binary operation, when you find the cosets of this thing, you can show fairly readily that it's normal, right? I've not gone into that in detail, but showing that this is normal should not be too hard. Okay. All right. Now this group, what form does it take? Well, now it's a direct product, right? So it's a set of ordered pairs of this form. Okay. Now I've written it out in a full notation, but I could just call it A comma B in shorthand, but I've written it out in full here. So with square brackets, and I've written the modulus each time. So it's mod 4, mod 8. Okay. So your A here can, that will range over 0, 1, 2, 3, because it's 4 here. And your B here will range over 0, 1, 2, ... 7. Okay. So how many possible ordered pairs will you have? Well, you'll have 4 times 8, right? So you'll have 32 possible ordered pairs. So the order of this group is 32. Okay. All right. So now we have deduced that the quotient group, here it is, this quotient group, assuming this is normal, the quotient group is of order 8, right? 32 divided by 4. So hence 8 cosets. So let's find the cosets, and that will help us figure out what kind of group this is. Right? So let's find the cosets, because once we've got the cosets, then we could build the group table. Right? Once we have these cosets, we then have the elements of this quotient group, right? Because a quotient group is a set of cosets. Now, interestingly, 8 cosets, 8, okay? But the number of elements here is 32. And remember, your cosets are just some element of this, or your left cosets, is just some element of this, call it little g, left multiplied by h, right? So it'll be little g, h, that's your left coset by definition, right? Now, there are 32 of these little g's here, right? 4 times 8, there are 32 of those little g's. Little g times h. So, in other words, 3/4 of those left cosets are repeats. Okay, 3/4 of them, because we know the quotient group must have 8 cosets. So the other 24, in other words, 3/4, are repeats. So we throw them out. Right? We in forming this quotient group, look under the set, it will have 8 elements, 8 cosets. Okay, which 8? Next problem. Right? And what we'll do here now is a technique that you will use later for doing this example 4. Right? So I'll spend quite a bit of detail, a bit of time on how to solve this problem, and then you can carry over those techniques to solve this one. All right. So let's start. So what we're going to do now is find these 8 cosets. In other words, how to eliminate the other 24. On what basis? How to do that technique, and you will use that technique to do this, and the exercise at the end of the chapter, the problem-solving session. All right. Okay. So this is your H, right? It's your normal subgroup. So it's of this form, right? Here, I've just written it down here, written it down again, and I've expanded that in. Not in shorthand. I've actually done it right here. So I've repeated this again here because I'll use it. All right. Now, so that's our H. Now we can put a little g in front here. G is just any one of the 32 elements of big G, the group. Okay. So let's just take the first 4. G's, little g's, the first 4 elements of big G, the group. All right. Let's form the first 4 cosets. Right. Remember, a coset, left coset, is just little g times h. Your h is your subgroup, right? And we're assuming it's a normal subgroup. Okay. All right. So let's form the first 4 cosets. So it'll be like little g h. Now, what's the binding operation in the context of residue classes? It's plus, right? Just simple addition. Well, it's not simple. I mean, you're adding this to this. All right. Now, okay. So add this to that and to that and to that and to that. Okay, so you now it's this plus, in a sense. I will add this 0 to that 0 to give me this, and I'll add this number here to this one, so it will be 0, 0, and then I'll add this to this one. So I'll get 0 plus 1, that's 1, 0, 0. Okay, so I'll get 0, 1, 0, and, well, in fact, adding zeros to all of these, no change. So I just get the same. I just get H, in other words. So this is just H, not surprising. Okay, now let's take the second element of G. Now, I've listed, here are all 32 elements of this, of your big G, your group. Okay, so 0, 0, 1, 0, 2, 0, 3, 0, and then 0, 1, 1, 1, 2, 1, 3, 1, and so on. And then 0, 2, 1, 2, 2, 2, 3, 2. Okay. Dot, 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 dot. 3, 5. Oh, that's all right. No, 0, 7, 1, 7, 2, 7, 3, 7. Okay, there's your, there are your 32 elements. Okay, so let's just take the first 4 of them, right? And so little g1, little g2, little g3, little g4. The first 4 elements of this group. So, and we'll form the first 4 cosets with them. Okay, so coset 1, coset 2, 3, 4 of 32 possibles, right? Okay, so you're adding this to H. So you add this to these 4 elements, and you get this. And then the next, little g2, this one, right? So little g2, H. So you add that to that, and you'll get this, right? And now the third coset. So we add the third element, GH.